All right. This next problem, this is the number 3 that I started in, number 3 I started in class that didn't quite get to finish to my liking. And there's a technique for solving this that I wanted to introduce at more length, and if I had more time I would have done so. But here you go. Here's the take on that. So when we are asking you to find the intervals, or the question ultimately says, when is this function concave up and when is it concave down? We will look at the graph so you can kind of have a sense of where the concave up and concave down happen. We're not going to do what sometimes are called the sign test. I just want you to look at the picture or the graph itself. Here's the first derivative. Little quotient rule, low d high, less high d low, over the square of low we go. So you can double check that. Make sure you're good with the first derivative. Then simplify it. We did this in class with with errors as I was going through pretty quickly, but we rectified those. What we finished with in class was correct. It was just not set up as nicely as I would have liked. Then if I really simplify, those 2x to the thirds cancel. This is f prime at its simplest. Okay. Then we take the derivative again, another quotient rule. And if I were to even take the derivative again, maybe a possibility, if you don't like using as is, there would be a chain rule dealing with the denominator if you did the quotient rule right now. So if you like, I'm going to go ahead and expand that out and make the polynomial there just in case that would help a few of you. So here goes. Now that I have it in this nice simplified form, there's low and then d high, less high, d low, over the square of, low we go. And that's good. That's a fine derivative. Oh, I forgot the squared there. I'll put it back here in a minute. But the if I simplify this, distribute the 14, and the numbers get big, and then the 14, negative 14x, you want to be careful that that negative goes along with it. So negative 14 gets distributed. This is the result down here. Let's go ahead and expand this out. Again, I forgot the squared again. What's going on with me? The like terms that you can put together, I underlined so that you can see those. And if I combine the like terms, there we go, got the squared back in there. That's the second derivative in a nice, pretty simplified form. If I'm going to find inflection points, so the graph is concave up and concave down in and around inflection points. That's where you have a change in concavity. So I need the inflection point so I can determine when a concave up section ends and a concave down begins. So I'm going to set this equal to 0, but remember we only focus on the numerator when we're dealing with a fraction. That's the only part that needs to be 0 for this to work. So here's the numerator. And we're going to set it all equal to 0. I'm going to divide through by 14. If there's a common number you can divide out, because the numbers here are really large, and while it's set equal to 0, I can divide through by negative 14 and make these numbers much more approachable, because I'm going to treat this like a quadratic. And I know it's a little strange looking with x to the 4th and x squared, but that's still quadratic in form, and because quadratic is, if you have a variable 2 degrees higher than the next form of that variable, then it's quadratic, and then this term has no degree with it, so it's just a constant. This is still quadratic in form, so we are going to use the quadratic formula. The crazy thing is we're not solving for x this time, we're solving for x squared, because this is a squared version of what's usually quadratic. You usually have x squared plus 2x minus 3, something to that effect, and we solve for x. But because it's x to the 4th and x squared, we have to ramp it up degree of 2 for that purpose. So I'm solving for x squared instead of x. Here's the quadratic formula. You set it up the same way. Still negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the same as usual. And when you put all those numbers in and simplify a little bit, you get this. And that 784 is a perfect square. It's actually square root of 784 is 28. So I get 2 results. The plus or minus means 2 different answers. For the plus, I get 14/6, which reduces to 7/3, and then for the minus, I get 42/6, or negative 42/6, which is actually just negative 7. Those are x squared values. I'm still solving for x. Like I want to know, when I say solve an equation, that means find we're dealing with x in the equation. You find out when x, or what the value of x is, not x squared. So I just take that x squared, and to get x, I square root it. And remember, there's always a plus or minus that goes with square rooting. So, and then down below, I use the other solution, which is negative 7, square root both sides of that. And the square root of a negative is not a real number, it's an imaginary number. And we're only interested in real outputs. We're not dealing with imaginaries. So we're going to consider that as not a real number. We're going to ignore it, the square root of negative 7. So our solutions are plus or minus the square root of 7/3 that we got for x. So just a quick recap. If you have this x to the fourth and x squared form of the quadratic, you're solving for x squared in the quadratic formula, but then when you're done, you still have to take the square root of that value so you can get x by itself. We still just want x. It just takes an extra step to get there. So now we got our two solutions, and what we'll do with those is we're going to look at the graph. It's about 1.53. If you look at the graph of this, which I have down below, there's 1.53 and negative 1.53 on the other side. Those are my places where the concavity changes. So we have concave down outside of those two values, and in the middle is concave up. So for the answer that you put into my math or WebAssign, oops, I think I wrote those in. Yeah, wait just a second. Let me get to the end here. Concave up is in the middle region from negative the square root of 7/3 to positive square root of 7/3, that middle green section. Concave down is in the region on the left and the right with the infinity in there. Now remember, you type in capital letters infinity into WebAssign for your result, but this is how it's done. You have to have the inflection points in order to know where to stop the intervals for concave up or concave down. Hope that helps. Let me know if you have other questions via email, and we'll talk soon.